Assalamualaikum class. Today we have exact ordinary differential equation. First order differential equation is represented by y prime of x equals to phi of xy. It can be represented in the form of m function of xy into d of x plus n function of xy into dy, where exact differential is df equals to m dx plus n dy, where n is partial f by partial x and n is partial f by partial y. If this relation is satisfied, then we say the given equation is exact, which is partial m by partial y and partial n by partial x. Let's do one of the example. For example, we have one question. In this, exponential x into cos y minus 2x dx plus 2y minus exponential x into sin y dy equal to 0. First we check either it is exact or not. To check exact, we must satisfy this relationship. This is our m and this is our n. We differentiate partially m with respect to y. The derivative of this m with respect to y, we have minus exponential x, cos is sin y, and this 0, and similarly here we differentiate n with respect to x. Here it is 0 and here x we have minus exponential x and sin y as it is. Now we see these two are same, so the given equation is exact. Now we are going for the solution. For solution, we first find p, which is m into d of x. We integrate m with respect to x, and our m is exponential x into cos y minus 2 of x. So p will become, the integration of this function with respect to x would be exponential x and cos y, and from here we get minus 2 x square upon 2 plus some constant. This 2 and this 2 will be cancelled out, and we have only x square. In the next step we find q, which is integral n dy. Again our n is 2y minus exponential x sin y into dy. We integrate with respect to y, so q will become, here we have 2 times y square upon 2, and here this is minus sign. We are doing with respect to y, so integration of sine is minus cosine, that minus and this will become plus, so we have exponential x into cosine y plus some constant. This 2 and this 2 will be cancelled out. Now in the next step we find r. R is the common terms of p and q. So the common terms of p and q. So r will become, we see the common terms are exponential x cosine y and exponential x cosine y. So we have exponential x cosine y plus any constant. Now in the last step we find the solution, which is d of f equals to p plus q minus of r, and our p is this, which is exponential x cosine y minus x square plus constant, and q is y square plus exponential x cosine y plus constant, and r is this one, we subtract, so minus exponential x cosine y minus constant equals to 0. So this term will be cancelled out and we have solution only exponential x cosine y plus y square minus x square, and these three are the constants c1, c2 and c3. We write only one constant which is c, and this is our answer. Alright class, we have one more example. In this 2x ln y plus 1 plus 3y cos 3x minus 1, it is our m, and x square upon 1 plus y plus sin 3x plus 2y square, and this function is our m, and this is our initial condition when y is 0, x is also 0. So first we check either it is exact or not. We differentiate m with respect to y. So when we differentiate this m function partially with respect to y, we have 2x as it is, and the derivative of ln y plus 1 with respect to y is 1 upon 1 plus y, and from here this y partial derivative would be 1, and remaining we have plus 3 times cosine 3x. And now for n we differentiate partially with respect to x, so the derivative of x square is 2x and 1 plus y as it is, and from here the derivative of sin 3x is cosine 3x with multiply by 3 times cosine 3x, and this derivative would be 0. Now we see this m of y and n of x, these are equal, so it means the given equation is exact. Now we proceed for the solution. So first step is we write p, which is integral m with respect to x. Our m is 2x ln y plus 1 plus 3y cosine 3x minus 1, and this dx as it is. So we differentiate with respect to x, p equals to, so we are working on x, so this ln y plus 1 would be outside, and here we have 2 times x dx. Similarly, this 3y would be outside, and we have cosine 3x into d of x, and here we have 1 time d of x. So we see that the integral of this is x square upon 2. So p is equals to ln y plus 1 and 2 times x square upon 2, this plus 3y as it is, and the integral of cosine is sine, so sine 3x, and in divide we have 3, and this d and integral will be cancelled out, and we have minus x plus some constant. This 3 and this 3 and 2 cancel out, and final p we have is x square into ln y plus 1, and from here we have plus y times sine 3x plus some constant. This is our p. Now we proceed for the q. For q we have integration n dy. So n is this complete term, we write n here, which is x square upon 1 plus y plus sine 3x plus 2y square, and here we have d of y. Again we are going to integrate with respect to y, so x term will be outside, x square outside, and here we have 1 upon 1 plus y dy, and here we have plus sine 3x outside, and inner we have dy, and from here 2 times y square and dy. We see that the integral of 1 plus y would be 1 upon 1 plus y, the integral of this is 1 ln 1 plus y. So q becomes x square ln 1 plus y, and here we have sine 3x, and this d and integral cancel out, so we have y sine 3x. Similarly here from 2 y cube upon, this is y square, so we have y cube upon 3 plus some constant c1, so here we have c2, and this is our q. Now we write the r term. We know that r is the common of p and q, so we see the common is x square ln y plus 1 and x square ln y plus 1, so one term is this, and similarly y sine 3x is here and y sine 3x is also here, so this is also common, so plus y sine 3 of x, and write down plus some constant c3. We have done p, q and r. Now we write down solution. df equals to p plus q minus r. P is x square ln 1 plus y plus y sine 3x, and q is x square ln 1 plus y plus y sine 3x plus 2y cube upon 3 minus time r. So minus, we operate with this, we have minus x square ln 1 plus y minus y sine 3x, and equals to c1, c2, c3, we write only one c. We see this will be cancel out, minus y sine 3x and plus y sine 3x and minus x square, and this will be cancel out. So last we have y sine 3x plus x square ln 1 plus y plus 2 times y cube upon 3 equals to constant. Now we impose the initial condition which says when x is 0, y is 0. So when we put x and y both 0, this will be 0, and here again this is 0 and this is 0. So C answer would be 0. Our C is 0, and we write down 0 answer instead of C. This is 0 and this is our final answer. I repeat one more time what we have to do in exact. First we check the derivative of m with respect to y. We partially differentiate m function with respect to y and n function with respect to x. If they both satisfy the relation, then we say that these are exact equation. In the next step we find p. P formula is m dx. M is this first term. What we do, we take the y terms outside and integrate with respect to x, and for q we have formula n dy. We differentiate, we integrate with respect to y, and we take the from this n we take outside and x terms, x outside, and we integrate with respect to y. After p and q we have r. The formula for r is the common terms of p and q only. So we see that this and this is common, both have this y sine 3x and x square ln 1 plus y. After this we have final answer, which is p plus q minus r. We write p, we write q, and minus r means this sign will be changed and some term will be cancelled out, and we impose the initial condition, find c and write down the c value in the last step. I hope it goes well. Thank you.